This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about Model Paper 2. So in this, from module Corrosion, there are various questions. So now in this session, I will explain the Model Paper 2 questions with solution answers. So the Model Paper 2 questions and answers topic related to this corrosion. So in this, they have asked question, enlist the various methods used for prevention of corrosion. So what are the methods available, various methods for prevention of corrosion? So here are various methods used for the prevention of corrosion given one by one. So we will see electrochemical protection or cathodic protection. So electrochemical protection or cathodic protection. So this is one method. The principle involved in the electrochemical protection or cathodic protection is to force the metal to behave like a cathode. So in this, in theory part already we have learned. So in this, the important principle is the electrochemical protection or cathodic protection is to force the metal to behave like a cathode. There are two types of cathodic protections are there. So one is sacrificial anodic protection. Another one is impressed current cathodic protection. One is sacrificial anodic, another one is impressed current cathodic protection. So now detailed explanation we will see. The sacrificial anodic protection, in this method, the metallic structure to be protected to behave like a cathode by connecting it with more active metal. So that is called as anodic metal. So in this, the main principle is the structure, the metallic structure to be protected to behave like a cathode. Here, seen in this diagram, the pipeline. The pipeline is acted as a cathode. So by it is connecting it with more metal, that is sacrificial anode oxidation, so that all the corrosion will concentrate only on the active metal. The artificially made anode thus gradually gets corroded, protecting the original metallic structure. So artificially made anode, thus gradually gets corroded. So protecting the original metallic structure. So here you want to protect this pipeline from the corrosion. So in this case, the corrosion will concentrate only on the active metal. Which one here active metal is? The magnesium. Here taken magnesium. So this is called as sacrificial anode. So protecting the original metallic structure. Hence, this process is otherwise known as sacrificial anodic protection. So one is aluminum, zinc, magnesium are used as sacrificial anodes. So sacrificial anodes are aluminum, and zinc and magnesium materials are used as sacrificial anodes. So see, in this diagram given examples, the important applications of this method are: one is protection of underground cables and pipelines from soil corrosion. The pipelines from soil corrosion. Another one is the protection of the underground cables and underground pipelines. So next one is the important applications of this method are protection of ships and boat hulls from marine corrosion. So the hull of the ship protect from the corrosion. So due to various acidic reactions and various environmental conditions, the corrosion will be formed. So to protect this corrosion, this type of protector, this type of corrosion, you can control by using this method. The important applications of this method are prevention of rusty water, inserting magnesium sheets or rods into domestic water boilers or tanks. So the prevention of water, rusty water, by inserting magnesium sheets or rods into domestic water boilers, you can see this type of corrosion you can prevent by applying this method. So next one is impressed current cathodic protection. So in this method, an impressed current is applied in the opposite direction of the corrosion. So opposite direction of the corrosion current to nullify it. And the corroding metal is converted from anode to cathode. Converted from anode to cathode, this method, the impressed current, is applied in the opposite direction. So this can be done by connecting negative terminal of the battery to the metallic structure. So which metal to be protected? That is connected to the negative terminal of the battery, and positive terminal of the battery is connected to an inert anode. So one is a negative terminal of the battery to the metallic structure, and another positive terminal of the battery is connected to an inert anode. The inert anodes used for this purpose are graphite platinized titanium. So the anode is buried in a backfill. So that is containing mixture of gypsum, coke, grease, sodium sulfate. The backfill provides good electrical contact to anode. The applications are structures like tanks, pipeline, transmission line towers, underground water pipelines, oil lines, ships, etc. can be protected this method. So the applications of this impressed current cathodic protection used in structures like tanks, pipelines, transmission line towers, already we have discussed in the corrosion theory part. So etc. Many applications are there. It can be protected this method. Next, surface coatings. This is another method to protect from the corrosion. The surface will be protected by applying these coatings. The surface coatings, metallic coatings. The surface coatings are used to protect the metals from corrosion. The surface coatings acts as a physical barrier between the coated metal surface and the environment. So, however, they are also used for decorative purpose. For decorative purpose, also using this type of coatings. The primary application is to protect the metal from the corrosion. The surface coatings acts as a physical barrier between the coated metal surface and the environment. The metallic coatings. The surface coatings made up of noble metals are known as metallic coatings. So the metallic coatings are mostly applied on steel and iron surfaces because they are cheap, commonly used construction materials. So they are very cheap, commonly used in construction materials, these metallic coatings. So what are the methods of applications of metallic coatings? So metallic coatings are done by the following methods. 5 methods are there. One is hot dipping and metal cladding, cementation, electroplating, and electroless plating. These are the methods used for metallic coatings. By applying this method, the coatings are to be applied. So one by one we will see. One is hot dipping. Hot dipping process is applicable to the metals having higher melting point than the coating metal. So whenever the metals having higher melting point than the coating metal, the hot dipping process is applicable. Actually, it consists of immersing well cleaned base metal in a bath containing molten coating metal and a flux layer. The flux cleans the surface of the base metal and prevents the oxidation of the molten coating metal. So examples: coating of zinc, coating of tin, lead, aluminum on iron and steel surfaces. So most widely used hot dipping process are: one is galvanizing and tinning. So the hot dipping is the metal coatings are different types, classified into different methods: hot dipping, metal cladding, cementation, electroplating, electroless. So again, this hot dipping classified into two. One is galvanizing and tinning. So the galvanizing is a process in which the iron article is protected from corrosion by coating it with a thin layer of zinc. At first, iron or steel is cleaned by pickling with dilute H2SO4 at a temperature range of 60 to 90 degrees centigrade for 15 to 20 minutes. Therefore, it removes scale, rust, and other impurities present. So then after the dipped into molten zinc, that is temperature having 425 to 450 degrees centigrade, to prevent it from oxide formation. So the surface of bath is covered with a flux, that is NH4Cl. When the iron piece is taken out, it is coated with a thin layer of zinc. And to remove excess zinc, it is passed through a pair of hot rollers. Lastly, it is annealed at a temperature of 450 degrees centigrade and then cooled slowly. So this process is called as galvanizing. So what are the uses of this galvanizing process? It is used to protect roofing sheets, pipes, wire screws, etc. So disadvantages are: zinc is toxic. Thus, galvanized utensils cannot be used for preparing and storing food. So this is the disadvantage. This zinc is toxic. Why? Because so that you can't use it for preparing and storing food containers. Because zinc dissolved in dilute acids to from highly toxic compounds. Next one is tinning. The process of coating tin over the iron or steel articles to protect it from corrosion is known as tinning. So tin is a nobler metal than iron, therefore it is more resistant to chemical attack. In this process, the first iron sheet is treated in dilute H2SO4 pickling to remove any oxide film if present. And then the cleaned iron sheet is passed through a bath, that is molten flux like zinc chloride, and then through molten tin, and finally through a suitable vegetable oil. Lastly, it is passed between rolls to adjust the thickness of the thin layer, which may be about 0.002 mm thick. So metal cladding. The process of sandwiching a metal between two corrosion resistant metals is called metal cladding. The base metal is placed in between two sheets of coating metal and passed through rollers under the action of heat and pressure. Next uses aluminum clad. A plate of duralumin is sandwiched in between two layers of pure aluminum to improve its strength and corrosion resistance. So the main uses is improve the strength and corrosion resistance. It is used in aircraft industry. The copper clad steel. It is used in electrical industry because it has high strength and good electrical conductivity. Cementation. Next method. The diffusion of coating metal into the base metal resulting in formation of layers of alloys of different composition. So the base metal heated with powder of coating metal and then metal diffuses into the base metal, that is shieldizing. Coating metal is zinc. Chromizing when coating metal is chromium. Colorizing when coating metal is aluminum. Colorizing when the coating metal is aluminum. So advantages are coating obtained are uniform in thickness. And then steel obtained after shieldizing is used as nuts, bolts, etc. The chromized steel is used to protect gas turbine blades. Colorized steel is used for making furnace parts. So these are the advantages of this method. Next, electroplating. So it is the process in which the coating metal is deposited on base metal by passing direct current through an electrolyte solution. So that is containing soluble salt of coating metal. So here in this figure you can see the key. The object is cathode and the impure copper is acted as a anode. The solution electrolyte solution containing soluble salt of containing metal. This is electrolyte solution. So the electrons flows from one anode to cathode. So electroplating of copper over metal object. So here the detailed diagram given shown in this slide. Anode pure copper plate, that is the construction method, and cathode is base metal to be protected. Which metal you want to be protected, so that metal will be acted as a base metal, that is cathode. And electrolyte CuSO4 solution. See anode copper coating metal or graphite and one inert anode, and then here cathode is article to be coated, and electrolyte solution here soluble salt of coating metal. Applications of electroplating. This process is widely used in automobiles, aircrafts, etc. Plating for decoration. This process also used in refrigerator, jewelry item, radios, cameras, and typewriters, umbrellas, watches, etc. Plating on non-metallic materials. So here gold plated watch you can see in this diagram. Copper plated mug, silver plated teapot, and silver plated goblet, and chrome electroplated tap. So next, electrolysis plating. It is a technique of depositing a noble metal on the base metal by using a suitable reducing agent without using electrical energy. So electrolysis plating. See this, no need of electrical energy. The principle is reducing agent reduce the coating metal which gets deposited on base metal. So coating metal ions, reducing agent, coating metal plus oxides products. So metal metal ions, reducing agent. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.